questions. So Abhishek asks, how much of the multimodal guest lecture, for example, transformers, will we have to understand for the final exam? So for the final exam, you should know what transformers are. You should know the basic properties of the different neural architectures. So you should know what a CNN is. You should know what an RNN is, an LSTM. You should know what a transformer is. And this doesn't mean that you would be able to give a complete description of them and everything about them, but you should know what these architectures are and what they're good for, and some about their properties in terms of where they might be used, for example. Um, so does that address your question, Abhishek? So you do need to know the things from the multimodal guest lecture. There probably will be an exam question that draws heavily on that lecture. So you will need to know that stuff. Does that answer your question? Yeah, so you don't need to be able to draw a diagram of a transformer and talk about all of the math behind it. You should know what attention is and self-attention. If you know that and you know the basics, you'll be fine. Any other questions before we get started? Okay, today we're going to talk about one of my favorite topics, which is multilingual NLP. NLP for a multilingual world. So in this course, mostly we've been talking about English NLP. Your project is on English NLP. The examples from most of the lectures were from English NLP. And this has to do not just with the fact that we're taking this class in an English-speaking context, and English is the common language that we all share, but with the fact that a lot of NLP research has been done in English. There are a lot of data sets, for example, that only exist in English. There's no equivalent data set in another language. And so people sometimes kind of assume that languages are languages. And if you can do it for English, if you have a solution that works for English, you have a solution that works for any language. And so you only need to worry about making sure it works for English, and then the other stuff is trivial. But it turns out to be not quite that way. And that's some of what we'll talk about today. That when you move beyond English NLP, there are some other interesting kinds of challenges and also opportunities. And so we want to talk about that. So first, I shouldn't have shown that. How many languages are there? Well, according to this one source called Ethnologue, which is a catalog of languages of the world, there are over 7,400. Is that higher or lower than you would have guessed? That is, would you have guessed that there are more languages than that or fewer languages than that? So Abhishek says, depends on what consists of a dialect versus a language. And that's something that we're going to talk about. The dialect language distinction. We'll find that these terms are used in different ways by different people. And when linguists use them, then they mean one thing. And when normal people use them, then they mean another thing. And these things do not align with one another. Um, we'll talk about that in a minute. Crystal says, um, are we only talking about official languages? And the answer is no, of course not. So in terms of languages that have some official status in some country, then it's much smaller than that. It's in the hundreds um, rather than the thousands. So these are, how are we defining language here? To get back to Abhishek's question. Well, Etholog, when they determined what is a language, what are distinct languages, then they used something called Lexico Statistics. So they took lists of words in each of the language varieties that they wanted to compare. And if the number of cognates, that is the number of words that obviously have the same origin between any two languages was above a certain, or any two varieties, was above a certain threshold, then we say these are not distinct languages. These are dialects of the same language. If it was below that threshold, then we say these are separate languages. These are dialects of different languages. And sometimes these decisions were not made as explicitly as this, but this is the ideal kind of methodology. So the criterion that is used, the basic criterion is one of mutual intelligibility. So if two language varieties are mutually intelligible, if speakers, the people who know only those varieties, can talk to each other with no prior exposure, then we would say that these are not separate languages. These are dialects of the same language. So for example, American English and British English are different. In fact, there are many different British Englishes, different varieties of English spoken in the British Isles. And, but like standard British English or received pronunciation and American English. So if we have two people who've never encountered the other and we put them in a room, they can talk to each other. They can carry on a conversation. So we would say that American English and RP are dialects of the same language. But a speaker of English and a speaker of Dutch would not be in the same situation, even though Dutch and English are quite closely related. It's still different enough that Dutch speakers and English speakers can only understand maybe 5% of, without prior exposure. So we'll get back to this issue in a little bit, but this is an important one with regard to language technologies, because dialects require some special treatment, but when you have completely separate languages that are mutually unintelligible, you often have to have completely separate models, completely separate data, and so on. So here's a map of languages in the world. So you can see where lots of languages are spoken. Let's see if this works. So each of these little green dots is a language. And you'll see that in North America, so English is a dot in England, not in North America. And in North America, there are a lot of languages that are indigenous to North America. Most of them are dying out, so they're very small languages. There were a lot more languages in Mesoamerica and South America. And in Africa, there are a huge number of languages, very high density through Western Central Africa. India has a high density of languages when compared to the Middle East and Europe and so on, and Central Asia. Southeast Asia has a lot of languages, and the place with the highest density of languages, according to this ethnologue kind of definition, is New Guinea, which is the island north of Australia, right in the center there, where about a quarter of the world's languages are spoken. So there are a lot of languages in the world, and a lot of the languages are concentrated in places where the money is not concentrated. So a lot of these languages kind of get ignored, especially since many of them are spoken by a rather small number of people. But some languages you may not have heard of are spoken by a very large number of people. And most people in the world, in the history of the world, most people have spoken more than one language. Who here speaks two languages? Raise your hands. At least two languages. Now, put down your hands. Who speaks at least three languages? Good. Put down your hand. So about 4 or 5 people. Who speaks more than 3 languages? So we got one person. So Moria, what languages do you speak?
Yeah, I can speak English, Hindi, Kannada, and Telugu.
Aha. Good. That's those are all big languages. All of them have lots of speakers, and they're all, I think, useful to know, right? Especially if you're in southern India, or Hindi if you're in any part of India, or the Indian diaspora. So most people speak more than one language, and most people in the history of the world have spoken more than one language. And here's an example of a language a language that I worked on in the past. And this is a language called Gajai. And speakers of Gajai mostly live in a single village in northeastern India called Gajai, in the state of Manipur, in Ukhrul district. And so people who speak Gajai speak this at home, but not really outside of home or village life. If they want to talk to people in neighboring villages, that are members of the same ethnic group, they speak a related language called Tangkol. And Gachai and Tangkol are what are sometimes called Naga languages, although that's a category that doesn't make very much sense. But for historical reasons, they're sometimes referred to as Nagas. But within, so up to the high school level, then people in Ukhrul district, like people in Gachai village, are educated in Tangkol. And it's also what they speak at church, because most of the speakers of Gachai, actually, I think all of the speakers of Gachai are Christians. They belong to the American Baptist denomination for the most part. And so they have church services, and these services are conducted not in Gachai, but in Tangkol. But they live in Manipur. And the dominant ethnic group in Manipur are called the Métis or Manipuris. And they speak a language that is distantly related to Tangkol and Gachai, called Métis. And that is used as the official language of Manipur state. So in official business, and higher education, like if they went to university at University of Manipur, then instruction would be in Métis and English. But people in Gachai village are not just part of a district and part of a state, they're also part of India. And actually, a lot of them kind of wish they weren't part of India, and so they've had this long-standing insurgency where they've tried to assert autonomy or independence. And for that reason, then there are a lot of Indian soldiers in that part of Manipur trying to suppress this insurgency. And for that reason, then people come into contact with a lot of soldiers, and they speak to these soldiers in Hindi. And that's also the connections to other parts of India are maintained in a large degree through Hindi. But because the people in Gachai village are American Baptists mostly, then they have this connection to America. And they get missionaries from America. They send people to get theological training in America, which is how I met the Gachai speakers that I met. And they're also part of an international community. And so they speak English, or many of them speak English if they're somewhat more educated. So it's not uncommon for somebody who lives in Gachai village, in fact, it's the rule, the general case, to speak all of these different languages and use them in different contexts to at least be able to communicate in all of these languages. So here's a question: what is a global language? And I would define this as a language that you might learn in school, like in a university, a language that you might study. Not as a special object of study, but as a general set of courses. So things like, well, it's mostly Mandarin, English, French, Arabic, Spanish, Russian, Portuguese, Japanese, German, Italian, now Korean and Turkish. Um, we might add to this Hindi, since a growing number of people outside of India are studying Hindi. But Hindi, there's been less of an incentive for people outside of India to study Hindi than for people outside of China to study Chinese or Mandarin, because of the fact that so many people in India speak English. So you just use English if you want to go to India or communicate with people from India. But Hindi is another huge language. So the point of talking about all of this is to talk about language technologies, right? To talk about NLP. So if you want to have NLP for your language, what are the basic things that you want? What are the technologies that you want to provide to a speaker of English, or a speaker of Hindi, or of Meitei, or of Tangkhul, or even maybe of Kachai, although it's one village, so it's sort of hard to develop language technologies for a language that's spoken only one place by a few thousand people. What technologies would you want? If you speak a language for which there are not really any language technologies yet, what would you want? What NLP things would you want for your language? Okay, so Abhishek says translation to or from more spoken language. So I think what you may be saying is speech translation. So you can do speech to speech translation. What you could be saying though is from the style of language, that it's more of that you want translation that works not just on formal written prose, but on spoken dialogue, or that register, that domain. Is that what you're talking about? You meant speech to speech translation. To from more spoken language. Okay, you meant speech. Yeah, so you want speech technologies probably. So you want like ASR, speech synthesis, and you want translation. You probably want MT of some kind, translation into, say, English or other global languages and from them. Speech to speech translation would be good. Aspirational, but good. What else? What do I need to make it possible to use my language with a computer or smartphone in the way that I do with English? So you need language modeling. Why do you need language modeling? Abhishek says you need a language model. Why would you need a language model? Abhishek says to be able to parse the language. Well, so language model doesn't necessarily help you parse the language. Although you may want parser as well. So a language model will help you to tell what a probable sequence in a language is. And this is used in a lot of language technologies. It enters into speech recognition, to machine translation, if you're using statistical machine translation. It also occurs other places too. So if you are using a smartphone and it does predictive text entry, predictive autocomplete, basically. How does it do that? How does autocomplete work? If you were to make autocomplete, how would you make it? Yeah, so it's based on language models. It could be based on an n-gram language model or another kind of language model. But basically, you're predicting the most probable word based on, or the most probable n words based k-words based on the preceding words. So you need a language model to do that. So what else would you want? What are basic things you would want just to use your language in a computer? Okay, this is a great one. Alex Campus says a good accessible input method, like speech to text, keyboard, appropriate to the language. That's a very important one that people sometimes forget about. That Val says spell check, and that's another important one. Like if people are going to produce documents in the language and they're going to be consistent in their orthography, then you want spell checking. Maybe grammar checking too, to some degree. What else? Keep them coming. So it helps to have a large corpus, Alex says, and this is true. But the corpus is not the technology. The corpus is the prerequisite to the technology. And that's often one of the things that is a limitation or a limiting factor for developing language technologies for smaller languages, is that it's hard to collect enough data to train a good language model or to do other things. And so that's you have to invest a lot in data in order to get things working. So here, let's look at some things. So we need keyboard input, which we mentioned, autocomplete, which we talked about, spell check, which we talked about, speech recognition, and speech synthesis. We didn't talk about information retrieval and search engines and morphology that you need to be able to do IR, information retrieval. But that's important too. Grammar check, translation, maybe question answering, which goes with information retrieval in a lot of cases. So these are the things that people use these sorts of things every day, right? Well, underlying these, there are a number of other things that you need to develop for a language in order to get everything to work. Language detection is very important because if you're putting together collections of data, for example, then you want to know which data is in the language of interest and which is not. So it's very important. Part of speech tagging, something that we've worked on a little bit in this class. Parsing. Nowadays, this especially means dependency parsing, meaning you may want to produce a dependency tree bank. Semantic role labeling, perhaps. Named entity recognition. So this is something I worked on a lot. It's named entity recognition for low resource languages. That means languages for which there are not a lot of data resources. So this is useful. NER is useful for a lot of things, although nobody goes and downloads the latest NER app onto their iPhone. It's not like something that's user facing, but it underlies a lot of other stuff. Summarization, translation again, and then information extraction and question answering. These are all things that companies, governments, researchers use to build this stuff on the first page. But in order to get everything to work, there's a lot of infrastructure that you have to have in place. And for a long time, one of the most annoying things about creating language technologies for a new language was character encoding. Because if you're old, you'll remember a time when every language had its own character encoding. Because you could only encode 128 or 256 characters in a set, depending on whether you had 8-bit or 16-bit characters. And so you had to shove, and so there wasn't room for every writing system in the world. There may just barely be room for your writing system. So you had a different encoding for every language and different fonts to go with that encoding and crappy rendering of the fonts. And life was terrible. Life really was awful. I spent too much of my time trying to convert data between different encodings of Chinese, like Big Five and GB, or different encodings of Vietnamese. And, it was a nightmare. And then Unicode came along. And Unicode solved a lot of these issues. So now people, when there's a language that isn't well represented yet in Unicode, there's a systematic process by which they can be added. And so Unicode now covers most of the scripts of the world. So you can write almost all of the living scripts in the world you can write using Unicode, which is a great accomplishment and something you should all be grateful for. Abhishek asks a question that is very important, which is, what if a language doesn't have a script? And some languages don't have their own script, but some languages don't have a writing system at all using any script. And one thing that Alan has worked on is developing language technologies for languages without scripts that are purely speech-based. And so you can talk to him about that. He would love to talk to you about that. But basically, there are things that you can do with representations, textual representations that are not scripts. And we can have like sort of phoneme level representations And so it's possible, but it's actually much easier to make a script, to develop a script, and which is also something I've worked on before, um, rather than just trying to work without one. And most, like when you come up with a new writing system today, most times you will use either a Roman or Cyrillic writing system, or a writing system of a large neighboring language, if it's compatible enough to work. So you need a way of representing it, probably in Unicode. You need fonts, um, and font rendering technologies. And then you need, as we mentioned earlier, input methods. Um, if you only speak English, then you don't understand how important this is. Um, but um, you need a way of inputting the language, text or whatever in the language, whether through a keyboard or um, through speech or through some other means. And another thing that's really important that people sometimes don't think about is you need a standard orthography. It's a standard spelling, basically, standard writing system. So it's part of a DARPA project that I worked on at one point. We were developing NER and some information extraction and machine translation for a language called Oromo. That's the largest language in Ethiopia. But it's not the official language of Ethiopia, and there was not an official orthography or writing system for this language until the 2000s. There was an unofficial orthography that had existed since the 1970s, I think, but it was not standardized. And so people didn't agree on when to write double vowels and when to write double consonants, which words to write those in. People just wrote it as they heard it, and there was dialectical variation. So there was a lot of variation in spelling. And it made things so hard because, well, why would that make things hard? Why would having no standard orthography make language technologies a challenge? So Abhishek says, you might not be able to identify different instances of the same word if the spellings differ. Yeah, so imagine you're building a language model, an n-gram language model. Then you have everything gets thrown off because the instances of what are really the same word are written differently. So you miss like you have undergeneralization, and it can lead to kind of sparsity, not just for language modeling but for other kinds of tasks. Because sometimes a word will occur, a spelling will occur very rarely. And so it looks like there are a lot of different words, but actually they're just a few words and they're just spelled lots of different ways. So so Zachary says, it's harder to store the words. And that's true in a sense as well, in that your representations are sparser. Um, and Alex says two completely different words have the same semantic meaning. Right. So you're missing the generalization that those words mean the same thing, because they were not spelled the same. And it's just this surface noise. It just injects noise into any model that you train. Um, so standardize your orthography. Like, get some people on the ground who will teach people to spell, and it will make developing language technologies much easier. And then the hard part, the hardest part maybe, is getting enough text or speech to train models. Which, depending on what kind of models you're trying to train, can be a lot of data. So here are some languages. These are actually the top 20 languages in the world in terms of number of native speakers. Ordered from biggest to smallest. And I want you to tell me which of these you think are likely to have most of these language technologies that we've listed off above. Which should I tick off? So Abhishek says the UN languages. I don't know which languages are the UN languages, so you have to be more specific than that. Okay, so among these are English, as Abhishek says, English, French, Russian. It's pretty good. Yeah, Spanish, Mandarin Chinese, and Arabic. Any others do you think are likely to have lots of these technologies? So probably Hindi. So Korean. So you think Hindi and Korean? Anybody else have any that they think? So German. Why German? German and Japanese. Why German? So Germany has, as Alex says, a high GDP, lots of resources. It's also one of the main languages in the EU. So any of the EU languages actually, because of subsidies from the European Union, has higher language development than you might expect from the number of speakers. There's a lot of investment of resources in developing these technologies. Any others? So Portuguese, why Portuguese? So it's in the EU. Portugal is in the EU. Um, Brazil is a huge country. There are also other countries where people speak Portuguese, like Angola and Mozambique. Although that's probably not the reason that they have pretty good that they might have good language technologies. But the EU thing is a big part of it, and Portugal and Brazil being a large population country um, that is middle income now um, has contributed. So let's look at uh, um, kind of assessment, of how much in the way of language technologies each of these languages has. And you'll see that we are basically right. Um, uh, Portuguese, for example, has a fair degree of development, though less than Spanish. Um, Russian and Japanese and French and Korean, and to a somewhat lesser extent German, all have good language technologies. But why? Well, so you'll note something interesting. Um, about some of the top languages um, that don't have much in the way of language technologies. What do Bengali, Punjabi, Telugu, Marathi, and Tamil all have in common? So Abhishek says any other Indian language is overshadowed by Hindi as a common language that's more likely to be invested in. And this is no doubt true that a lot more investment in technology for Hindi happens. Stuff gets plowed into Hindi rather than into these other languages, even though they have millions and millions of speakers. Bengali is, according in terms of um, native speakers, is the 7th largest language in the world. But it has very poor language technologies. I've worked a little bit on Bengali NLP, and there's a lot of text data, but there's not a lot beyond that of work. So one other factor beyond Hindi, so there's the Hindi factor, but there's also the English factor. When middle-class people in India use computers, how often do they use their native language, and how often do they use English? You who are from India, offer um, your experience. So Moria says almost always English. So some Andrew ID says, is it because the majority of higher education institutions that teach things like NLP are taught in English medium? And I think that's maybe part of it, but I think a large part is that educated Indians are used to using technology in English and taking advantage of all of the existing English technology that exists, um, anyway, um, that has been developed. And when, and even when language technologies are developed in India, then often they're for English because that's where the market is perceived to be. Now, is it true that most people in India want to speak English all the time and want to use computers in English only? I think probably not, based on um, my informal surveys. Um, but educated people are used to using English, and it's easier. You don't have to have complicated input methods. Um, yeah. So Abhishek says another thing that could matter is that a lot of Indian languages with the internet are sometimes used with romanizations instead of their standard written syllabaries. I'm not sure how much that affects things. You know, um, the big issue is it's hard for people to type Devanagari or the other um, uh, Indian orthographies. You have to have special input methods, and they're hard to get used to. You can't usually buy keyboards easily on commodity laptops or desktops that support that are made specially for those orthographies, and people might not want them anyway because they also want to be able to use English. Um, so it's like an obstacle. So people, to get around this, have developed romanizations for the different orthographies, ways of typing the languages in English characters, in Roman characters. But this is not a problem. Actually, this is fine, and could be the basis of good NLP as long as people um, uh, adhere to standardized conventions. Because you could even automatically convert back and forth between the orthography, the standard orthography, and the romanization. The problem is lack of standardization and agreed upon conventions. Um, but I think that as technologies, particularly things like speech, which are relevant for people who are not necessarily literate or not highly literate, as these become more pervasive with the spread of low-cost smartphones and things like this, then the attractiveness, then the market for language technologies in a lot of these other languages will really expand, and people will get used to using technology in languages other than English or one of these big global languages. So is it okay that language technologies only exist, for the most part, for the main global languages? This should say exist. What do you think? So even for a lot of these languages, there are significant language technologies that do not exist. But why do we need language technologies for other languages? Why aren't just the top 12 languages good enough? Why aren't Mandarin, English, French, Arabic, and Spanish enough? Why isn't English enough? Can't everybody just use language technologies in English? What do you think? Should we worry about this issue? So one thing is there's social and cultural reasons, as Abhishek says, um, wanting to prevent the extinction of many languages, and a lack of language technologies helps extinction along because of lack of convenience and use in daily life. Um, and not everyone is covered by the top 12 languages, especially in less developed regions. So there are actually two arguments here um, that can be made. One is a moral argument um, that we want everybody to have access to language technologies. And one is a cultural argument that we want to preserve languages and cultures, and giving them language technologies is one way of promoting them and helping them to be relevant to their users so they will stick around and not go extinct. Um, so I think those are both good arguments. Another argument is the economic one, which is that even if you reach the people um, for these top 12 languages or so, there's still a huge number of people in the world who don't speak those languages as their first language. And this is a potential market. So as technologies, as hardware becomes less expensive and data connectivity becomes less expensive, then it becomes the opportunities for um, sending, like data to sending or selling language technologies to people who speak these languages becomes greater. So Val says language tech in less popular language is also useful for things like identifying misinformation, finding planned crime, and so on. I think that this is definitely so, and I think that governments are also interested often in language technologies for low resource languages. In fact, this is true of the US government, which is why they paid me and Alan to various times work on low resource languages um, to gather intelligence and um, be able to communicate with people in areas where they speak primarily these lower resource languages, being able to gather information and process that information and build models of what's going on in the world. Um, so there are actually a lot of reasons for wanting language technologies for low resource languages. So we talked a little bit about dialects and languages. In China, there are a very large number of language varieties, language variants. So people speak Chinese in widely divergent ways. These include Standard Mandarin, Putonghua, other varieties of Mandarin, Shanghainese and other Wu varieties, Cantonese and other Yue varieties, Hokkien and other Min varieties, and then other groups of varieties like Jin, Gan, and Xiang. So if you ask a Chinese layperson or linguist about these varieties, they will refer to them as Fangyan. And Fangyan is conventionally translated into English as dialect, but it means something drastically different than the English term dialect as used by linguists. For linguists, a dialect is a language variety that belongs to a set of mutually intelligible varieties, just like American English and RP English from Britain are mutually intelligible. Therefore, they belong to a set of mutually intelligible varieties that we call a language that we call English. So Chinese Fangyans are written with the same script, and they're descended from a common ancestor, but they are often not mutually intelligible. For English-speaking linguists, the best translation of Fangyan is probably what? What do you think? Language. Why? So these varieties, like Mandarin and Cantonese or Shanghainese, or they're not necessarily mutually intelligible. They have different phonology, that is, their sound systems are different. They have different morphosyntax. They have different lexicon, different lexical semantics. And in many cases, it's not even really possible to use the same language technologies for all of these language variants. But people use them all the time, every day, in their day-to-day lives, in their families, in their homes, in their cities. And this is true despite efforts by the Chinese state to promote Putonghua. So it looks like people are just going to continue using these languages for the foreseeable future. And so for speech in particular, there's value to being able to target different Fangyan, different of these Chinese languages separately. But this is not a problem that is unique to China terminologically. So for example, there are a lot of different varieties of Arabic, of what people call Arabic, which people conventionally call dialects. So people will talk about Lebanese Arabic, or Maghrebi Arabic, or Iraqi Arabic, or Gulf Arabic. These varieties are not mutually intelligible, I should say. And they require completely different speech and often language technologies. Although people, when they write, often will write in modern standard Arabic, but then they speak in one of these non-standard dialects, these other languages. So India also has numerous minority languages, which are conventionally called dialects. And they're usually not mutually intelligible with regional or dominant languages. Sometimes they're not even related to a regional language. They're just a completely different language. But because they're not an official language, people call them a dialect. These require completely different language technologies. So the point here is that just because people call something a dialect doesn't mean it's not worthy of language technologies. It doesn't mean that it's not really a language in the sense that linguists use the term. Any questions about that? Did I offend anyone? Good, I don't like to offend people, but some people feel very strongly about Cantonese and Shanghainese being dialects instead of languages. So let's say you're interested. Oh, Abhishek has a great question. this may take us mostly to the end of the class. How can we use language technologies in one language to develop language technologies in another language? E.g., dependency parsing between languages that diverged recently. So this is an active area of research called cross-lingual transfer. And the basic idea, there are different things that you can do depending on how different two languages are or how many languages you're concerned with. But let's say you have a higher resource language, let's say Turkish, and you have a lower resource language, let's say Uyghur. And Turkish and Uyghur are quite closely related. They diverged less than 1,000 years ago, but they're still fairly similar to each other. So we want to do dependency parsing for Uyghur, but we have a bunch of Turkish data. Or let's say named entity recognition, since this is something I actually did. So they're written with different scripts, but structurally they're the same and they sound a lot the same. So one thing that you can do is you can convert both of the orthographies into phonetic transcriptions, basically. And then it pushes everything closer together. Then you can train a model that can match in some approximate way things that are phonetically similar. And you can train a model on Turkish and then tune that model on Uyghur. And you can get reasonably good performance, much better than you could if you just had access to a little bit of Uyghur training data. You can tune a Turkish model and get much better performance than the monolingual kind of model. So this kind of cross-lingual transfer is an important thing. And dependency parsing is an area where this has been used a lot. So there's a lot of research on what makes a good transfer language for dependency parsing and what kinds of models transfer well and what transfers, does it transfer lexical information or does it transfer syntactic information? And I can't cover all of that here, but that's something, but if you go to Anthology, ACL Anthology, which is Association for Computational Linguistics, and is their repository of conference papers, basically, and search for cross-lingual transfer, then you'll find very many papers about this, including some by people here at CMU and a lot by people elsewhere. That's kind of a cop-out answer to the question that I don't have slides prepared to address. But does that answer your question at all, Abhishek? So just before we close, I'd like to talk a little bit about some opportunities, educational opportunities available to students who are interested in endangered and low resource languages. And one of these is directed research. So we know a number of people and organizations who are interested in developing these kinds of language technologies for low resource languages. And if you're interested in working in this area, then we have a couple of things going on. this something in particular where I might be able to take some undergrads working on some languages of Mexico, Mixtec and Nahuatl. If you're interested in this sort of thing, it would be dealing with morphology and ASR, then let me know, and I'll see if we could fit you in. Alan often has opportunities like this available as well, so let us know. There's also an endangered languages seminar that's taught in the LTI. It's taught typically in the fall. So it was being taught right now. It'll be taught again next fall. But if you're still going to be around, it might be something you might be interested in. In the seminar, students learn about what language endangerment is. They learn about how languages get documented and revitalized, and how speech and language technologies can help. Also, if you're interested in learning more about languages generally in a way that relates to human language technologies, then a course that I teach with Lori Levin in the fall is called Human Language for Artificial Intelligence. This is an introduction to linguistics for computer science students. And you learn about the structure of language at all levels of abstraction, and it has a strong multilingual emphasis. So you learn not about English, you learn about language, and you see examples from a lot of different languages. Any questions about that? About these opportunities? Okay. Let's talk really quick about humans versus machine learning. So humans are great. They can understand the structure of language, differences between languages. They can write really nice, precise rules, but they have some disadvantages as well. For example, they're slow and they're fragile. They build systems that are fragile, that don't fail gracefully, because they have trouble managing statistical things. They tend to do things that are more categorical or symbolic. So humans also have to know the languages that they're working on if they're building NLP models. And it might be hard to find humans who both know the language and know NLP. And this, in fact, takes a lot of special talents. It's hard to find people who combine these two things and can do it well. So humans have one pro, but they have a lot of cons. Now, machine learning is also great. Nobody needs to know the language. The techniques are language independent. You don't need specially trained human linguists. It's fast. Once you have the data, you just fire up your model, and it's robust. You gracefully handle unseen data. But it has its downsides as well. It makes strange mistakes that a human wouldn't make, and it requires a lot of data. Not all languages have enough data. But that's okay. We can get funding for low resource NLP and do cross-lingual transfer and have stuff to write papers about. Well, here's the promise versus the reality. The machine learning promise is that nobody needs to know the language. The techniques are language independent. It's fast, it's robust. The reality is the techniques do not work equally well for all languages. And nobody knows why, because they don't deploy specially trained humans. It takes kind of a linguist working with a computer scientist to figure out why the models don't work equally well for all languages. The first versions can come up quickly, so they are fast, but it's taken centuries and hundreds of millions of dollars to refine NLP systems to the current level of performance in English, Chinese, and Arabic. And they're chronically unable to handle some basic linguistic constructions, resulting in wrong meanings. So there's some things that the machine learning models just have a hard time getting right, that a human would never get wrong. And here is an example of what happens when you take Google Translate. You give it an English original sentence, translate it into Arabic, and then back to English, or into Chinese, back to English. And one thing that you'll note is that Arabic English translation, or English Arabic translation, consistently gets higher BLEU scores than English Chinese translation. That is, English Arabic translation appears to be better in general. But this gives us some idea of the quality of these translations. And this was from, this particular set is from April 4th, 2016. And you'll note that the Chinese gets things pretty wrong. The Arabic is not quite right, but the Chinese is somewhat worse. Oh, the Arabic is actually terrible as well. But what's happened, this is from 2017, Chinese actually got a little bit worse, but Arabic got better. But as time has gone on, they've kind of converged. And although the Chinese is still worse than the Arabic, it's much better than it used to be. And the big jump occurred when Google Translate shifted to neural machine translation from statistical machine translation for the languages, for these language pairs. So it's the fluency and everything really improved. And the quality of the translation. But the point of all of this is that machine learning algorithms like those that are responsible for Google Translate are not language independent. They actually are influenced by aspects of linguistic structure that may not be obvious to the people who are building the technologies. So it's nice to talk to somebody who knows about the structure of the languages when you encounter this kind of challenge, and who can compare them and talk about why it might be that you're making certain kinds of errors, and see if there are ways that data can be augmented, or the parameters can be tweaked so that those errors don't happen as much. Anyway, we're now out of time, so we will stop there, which is roughly where I wanted to stop anyway. If you have any questions that I've not answered during this lecture, please feel free to post them to Piazza. And good luck with your projects. I hope that is going well. We look forward to seeing the questions and answers that you generate. And wish you all of the best. Take care, and I will, I guess I won't see you again in this form, but it's been wonderful having you in this class, and um, I hope to encounter you again soon.
Hey, I have a general question.
Sure.
Is there a final in addition to midterm 2, or is it just midterm?
No, the midterm 2 is the final, but it's
Oh,
really
okay.
midterm 2 because it's not comprehensive. There's so
Okay.
it's just midterm 2.
Okay. Thank you.
No problem. Okay, goodbye.
Bye.